Okay, let's start. So yeah, this is the paper. As you can see, this is the advanced paper for 2023 paper 1, and we already extracted the text forms, and we have to make diagrams now. So yeah, let's open the original paper. Where is the original paper list? So yeah, this is the original paper, and we are gonna make diagrams in this live stream. So from question number 1, let's not open this part, let's open it from here. That will be, I think, much better way to explain. So let's break it out. I don't know from where to. You start. No, I don't want this. I want left, right. I want like this. So actually, I don't know where the snapping part gone away. I used to snap this. I don't know. Toggle panel. No, it's not working anymore. So no problem. Let's proceed as we were working. So this is the diagram we need to make here, and I think we will be fine, I guess. So no problem. So yeah, first diagram is like this. There is a plane, and then there is a building of height 3h, then after a smooth curvature on top of that. So let's start from here. So this is the diagram node. Already we have. So firstly we have to use pick, add 0,0, no, pick let's say ground, add, and then we have to use frame. Frame which goes, let's say 10 centimeter. 10 centimeter is pretty large and will be sufficient, I guess. No, again one more thing I have to do here is we have to delete this, and then we can render now, and then it will be visual, I guess. Yeah, so now let's open. So yeah, as you can see, this is the plane we were hoping for, and let's drag this a little, and then we can so yeah, now it's okay. So this is the plane already we have drawn, and on top of that we are going to make a rectangle. So for rectangle, let's start, I don't know, let's continue this, accept this copilot thing, and as you can see it actually drawn pretty well, but this is not what we wanted. Actually we wanted firstly this, so we can shift this by shift is equals to maybe 3 centimeter. So yeah, we shifted 3 centimeter, and we can x shift as well. X shift is equals to minus 3 centimeter. That will be good to go. Yeah, let's change this to minus 5 or 4. Let's say minus 5. So this is perfectly fine, and few more things we have to do is to small this thing up, and then after we are gonna make this building kind of rectangular thing. So for that let's make a rectangle. I think I don't know what to do. Let's use this as a within a scope. That will be fine. Within a scope we can wind, and then after let's copy whole part in separate, and then we can make the building here. So draw, and for building we can make a rectangle, I guess. So say a rectangle, not 5,5 is like 4,4 will be fine, I guess. So 4,4 but I think minus 4 should suffice, and minus 3. Yeah, so this is the rectangle, and a few more thing we have to do is we have to scale this down. It's like 5 unit is too large, so let's say 3 unit will be fine. 3 unit will be fine, and then yeah, so this is how we can make this part, and let's drag a little 2 unit. So yeah, and we started this we can shift towards right, so instead of 0 we can start from 1, but it will mess the whole thing. So for that let's shift x shift is equals to 1 centimeter. Yeah, come in. This is the DPR. Sir, and once again I am no call, I am live. So after we save this part, and we can good to go. So yeah, this is how we can make the first building part, and a bit of change we can do here. It's like 4.5, so slightly towards the right side. Yeah, so this is perfectly fine, I guess. And as you can see in the actual picture, the terrace is a square shape, but we don't need exactly a square shape, and also the sliding curve part is not necessarily to be exactly a single curvature. Yeah, we can apply multiple curvature as well, so it doesn't matter. And we have to fill this rectangle part actually, so we can fill using lines or something. So for rectangular we can apply fill is equal to pattern, and pattern should be northeast lines, north patterns. Let's save it. No, patterns. I don't know. Let's say fill is equals to northeast line. I always forgot the command exactly. So yeah, something is not okay. North east lines, yeah, northeast lines is great. Yeah, so we have to apply directly pattern is equals to northeast lines. So it's fine, I guess. And a few more things we have to do is we can scale down the size of this slider. So we can apply 1.5. That will be better, I guess. Yeah, 1.5 is pretty good. No problem. So yeah, our half part is done, I guess, and now we can move on to next part, which is kind of projected. But I'm having confusion about the few parts here, because we shifted this whole thing as a single unit, and that will make this diagram bit complex. So we could have done this part as well. It's like in a single diagram we can make, and then we can define coordinate, and then after we can go from there. So I guess let's start from the beginning. Let's delete all this crap, and because that will be better, much better, I guess, in setting coordinates. So how can we start from the fundamental? So let's firstly draw this rectangle, doesn't matter, and we can actually use this word. So let's say tz coordinate 0, 0, which is O, and not 0, 0, we can say ground dash center, and then we can reference this O. So ground dash center won't do much. We have to shift towards left or right, so we can calculate here actually. So we want -4 unit towards left, so O will get shifted. Now we can reference this as O, and then we can use relative coordinates. So double plus indicates the relative coordinates. So yeah, as you can see, it is perfectly fine. And then we can move on to the next part, which is from, again, we have to use the coordinate calculation thing, because we don't want this slide thing from the O. We want something, it's like 0, 3, and then we can move it from S. So as you can see, it's pretty messed up, but that's because we are going to need to use relative coordinates. So a relative coordinate is always a better way to approach. Oh, we messed that thing up. Let's no, we messed thing up. From where? Oh, we messed thing up, and let's not do this. Let's we want from O, and then we can shift from we want shift along the y-axis. So along y-axis, and we don't have to use then relative coordinates. It's like a personal preference how you want to draw all these kind of geometries and all. So origin, I don't think we are making a right choice here. So let's say double plus, and then we can use double plus here as well, and that will fix, I guess. I don't know yet. And let's no, it is pretty messed up. I don't know what to do now. Bicep, let's continue this part. Actually we were fine previously, but oh yeah, we are making this mess because of this coordinate. So we are having this issue. So let's say 0 comma 0, let's say cycle, not use the absolute coordinate thing. That will solve the issue, I guess. No, it's not solving. What's happening here? Oh, we started from O, right? It's absolutely right. By we shifted by unit, and then what we did wrong? Yeah, that's absolutely fine, but last point is kind of messy. So let's say for right now 4 comma 3. Let's see what it does actually. Oh, so let's say 4 comma 0 because we shifted already. Oh, I know it's wrong. I think I have to make it from the ground up. That will be quite of work, and I don't want all this to do it again. That is the problematic part. So let's not shift by your x or anything, and then save it as normal. So as you can see, it is starting from this point O, but from O we want like this. Oh, and then we want from this. No, it's 2. Let's add plus here. Yeah, so I guess this is fine, and then we can use cycle. So yeah, it is fine, but not the way I wanted. It's like 3 comma 0 is quite long, and let's add plus 3 here. No, it is wrong. Oh, where we are doing wrong, man. No. Okay, let's say 0 comma 0. Yeah, it is fine, but I'm not understanding why it's happening. So I think we have to shift this whole system. This is the problem of latex actually, not the problem latex, because I'm being lazy here and I'm not. Oh, it's let's delete all this, and we will start from the fundamental. So yeah, so for right now we have only a platform which is in the shape of rectangle, and now we want a curvature like this, so it will be pretty fine, I guess. So let's firstly define few coordinates. So for that we have to define this coordinate firstly, and for that we're gonna say let's tz coordinate, and we want O as a, yeah. So for right now let's start the coordinate form which can represent the dot here. So it is pretty fine, and we're not going to use 2, 1 here. That will be fine. So this is the coordinate which we named A, but we want it's like we have to define H firstly. Let's define H. Let's use capital for right now. So H will be 1 unit, and H will be 1 unit, and we want this part to be 3 times H. No, we want 4 times H, and we want 3 times H to be height of this rectangle, and then after we can shift. So 3 is original, that means we have to do 4 unit from there. So yeah, so this is the point from which we are gonna drag this part. So it is fine, I guess, and then after from there we can start to make. So let's start from draw. We're gonna start. Yeah, so this is fine. No. What is happening? Actually, Copilot is not very good at suggesting in Tikz plotting. What should we do? In out is 180 degree, which is bad. Out is 180 degrees, great, but let's delete all these patterns, then see what happens. Yeah, it is fine, I guess. Better 2 times h. And this is minus h, and it should not be minus 90. Minus 60 will do the job, and it should be 3. So yeah, 3 is fine, and then let's do this 3 instead. So no, 3 will justify. So 180. I think, yeah, it's right, but not that right. I've wanted pretty like look like this. No, it's not okay. 70 is okay, but not that great. So let's do this 50 degree. So yeah, not 50 is okay. Let's 90. 90 is pretty steep, so 70-75 should do the job, but I don't know why I'm not feeling comfortable doing this. It's like not looking great. I don't know why. What should I? I should make this diagram like that. No, it's not happening. Let's move this 2 unit towards right. Maybe that will do the job, I guess. And this will be 2 unit, and yeah, so it's pretty good actually. So yeah, now we can use 60 as well. 60 will be fine. Yeah, so this is the way to go. So this is the sliding part, and actually we have to wrap this thing to, it's like we moved 2 unit forward. That means we have to move 2 unit backward, and then by will be 0. From then we can use cycle. No, why not? Yeah, why not? It's accepting the cycle part. Let's move 0 unit towards, and then h unit towards upward. That will do. No, it's not. Oh, sure. I am messing this dash part. Yeah, that because we are using actually dashed part. So now it will make perfectly fine. So yeah, this is the diagram, and now we can fill with the pattern, or we can fill using gray. 50% will be fine. So yeah, this is the sliding part, and the magic thing is like that, okay, we can shift the whole coordinate and it will shift according. Let's say we want like 1 unit towards right, then it will shift the whole geometry. Yeah, so that's why I wanted to do like this. So and let's we can fix this idea, I guess. 2 unit minus 2.5. so yeah, and for that we have to move 1.5, not 2. So yeah, it's good. So we name this coordinate A, and then after using the reference or relative coordinate, we just drawing this whole geometry thing. And let's move on to next part. So for that we have to name the coordinate again. So TZ coordinate again, we're gonna use the start version here, not because start version is necessary, but for right now, for the reference. And then after that, then we can remove the start version so that it will only reference the coordinate. So from A we want like 1.5 unit, sorry, 2.5 unit towards right. So h is the basically dimension of the dimension for the height is like this is the h. And then by we're gonna move minus h. Yeah, so we name this coordinate as b, or whatever, it didn't matter actually. So yeah, as you can see, this is the coordinate, we named it as b, and from b we want a like projectile, and from there we can move on. So few more things we have to do. It's like the diagram is pretty large, so we can use this like 0.5, so it will shift everything automatically. We don't have to do manual work. One more thing I have to take care is when we shifted this part, like when we shifted this part, the diagram didn't shift pretty well. So I have to, yeah, so because we are shifting this part, we have to 1.5 times h, so that will do the job. Yeah, so yeah, this is fine, I guess. And now if we want to increase the whole size of the diagram, we can do that without manual working. Yeah, so this is what I wanted actually. Yeah, I reached here pretty late, but doesn't matter. And a few more things. I think the height of this platform is okay, I guess, no problem. But few more things I have to do is like width of the platform is pretty wide. It's like, let's don't go there. Let's continue from here and move on to next part. So draw, we want a line which is from B to, and we want negative 3 times h. Yeah, it is fine, but in out should be 0. Out is great, but in should be not 120 negative, 120 is positive. 120 positive should be fine, or we can use parabola actually. Yes, we can use parabola, that will be good. Yeah, so this is the way to go in Tikz. So yeah, this is the projectile of this particle, and then after we can again make angle as well as let's firstly put the coordinate. So coordinate, let's call it C, and let's fill C with circle 2 point. Let's see what happens. So yeah, this is the coordinate C. We can remove all these later on, but for right now it's okay to make all these dotted coordinate system. And again we are going to make a parabola. So from C we want like parabola, and we want like a 2 unit rightward, 2 unit h, and then we can use 1 unit. So actually yeah, parabola, but it is actually upward, but we want parabola to be downward, and for that I don't have any or we can use 2. Yeah, let's use 2 part. We want out is equals to 45 degree and in to be 180 degree. So yeah, as you can no, out is in and out is not okay. What should we do here? Parabola, inverted parabola for parabola. Or sine will do the job, I guess. Yeah. So it depends on your need actually. Sometimes sine do the job, sometimes parabola. You can let's fix this. Let's move on to 3 unit. Yeah. So this is the projectile, and we want like 1.5, not exactly 1. That will look better. Yeah. So this is the projectile again, parabolic function. Actually sine function, sine and parabolic function are like so the same curvature for representation purposes, and we can all like shift this coordinate, like we plotted this parabola 2.5, then we can even make it 3 units. That will look much better. Yeah, so this is fine, but one more thing that we have to use double plus so that it will make a relative coordinate. Yeah, so now we have to use 2, and let's see on the Google for parabola actually. Tikz parabola. No. Visual text. Yeah, so this is the parabola actually. We can bend at a start. Yeah, so this is the optional parameter we were missing in the first section, so we don't have to use sine parabola, and then we can say bend at a start. One more confusion. Bend at a start, bend at end. Oh man, bend at end, and this will make the parabola, yeah, like this. So I think most of the part is done, and now we have to do the node thing, labeling thing, all this kind of geometry be drawn. We have to label all this. So first thing, we're gonna shift this towards -3. That will be better. Yeah, so it looks in the middle of the drawing, and we made this rectangular thing to be pretty like heightful, so we can not 3, 2.5 I guess will be fine here, and 4 is not, 3.5 will be better. So yeah, Oh, where did we miss? Where did we miss? For right now, let's keep 3 unit, because we have to change a lot of things here for that, and I don't want actually to shift this whole diagram thing. What should we do then? Let's change the height only, and the height will justify, I guess. No. This is the problem in the Tikz, or not in the Tikz, just like in general drawing thing, because you have to think before drawing anything, so that your diagram will like adjust accordingly. So I think no problem here. We are doing pretty good here. So let's move on to next part. So all these parabolas are dashed, so we have to use dashed, and again this is the dashed part. And add the in beer again coordinate, let's call it capital D, and fill capital D with 2 point. So this is fine, not 2 point, it's like it should be 3 point, I guess. So this is okay, and let's move on to not 3.5 will be fine. Yeah, so it is fine, and a few more things we have to. So let's start with this rectangular thing. So for that we are gonna make TZ line, and this would be the relative line. TZ line is the package from TZ plot. Yeah, so from O we want 0 unit towards X and 3 unit towards Y, and we want to name this node as 3H, and should be midway left. Yeah, and this whole node should be shifted minus 0.5 towards X axis. So yeah, this is what we wanted. Yeah, it's okay, guys, and we want this A part like should be labeled. So again we can actually copy this line, TZ line, and from A we want minus H unit this time, because we want downward, and then midway left, so it will be fine. Yes, so it's fine, and there is a bit of problem in drawing the object, which is the hardest part, I guess, because drawing object a small circle on this part is quite tough. Doesn't matter, let's proceed. So a few more things we have to do is we have to begin a scope, and we have to use TZ axis. TZ axis 0, 0 to 1, 1, and we want this to be X. Yes, and this to be Z, and whole this scope saying should be X shift is equals to 4 centimeter, and Y shift should be 3 centimeter. I think shifting, oh sorry, and there should be comma in between. So sorry, we actually put it 2 unit, which is bad. So yeah, as you can see, this is the coordinate system for the reference, and we can save this. It's like pretty wide, so we should move little downward and like that. It's the personal preference. So yeah, pretty good x coordinate and the z coordinate representing the coordinate system. And a few more things we have to do is we have to make a line thing. So let's decrease the document size a bit, and so that we can see nicely. So we want this D thing, so we named this coordinate as A, B, C. So from B we have to move 3 units downward and then move toward the C. That means after this parabola thing we have to use like TZ line, and this time not from O, we want from B, like, and B should be calculated, like it's like not directly we can use B, we can use B, but we want this horizontal line, so we have to get this coordinate. For that we have to calculate -3 unit downward, and then from there we have to remove this relative coordinate thing, because we have this absolute coordinate. So for that we can use just C, and not left, midway below we want, and this time not we want along x-axis, we want the shifting along the y-axis. So yeah, as you can see, D is perfectly fine. And next node is like this. We want, sorry, firstly we have to draw this like H thing, right? So already we named this coordinate as D. From D we have to move 1.5. so let's again continue this part, and from D we want like here again we can use relative coordinate -1.5 unit, and we can say H1, not H, and midway this time we want right, and X we want 0.5 into the right. So after saving we're gonna see this H1 part here. As you can see, this is the H1. So I guess a few more things we have left to do here. Let's zoom in a bit, already faced with it. So firstly we have to go for this G part. So G part is just after this rectangle. You can draw anywhere, doesn't matter, but for simplicity to understand later on, we are just making a node side by where needed. So let's use TZ line, and we want relative coordinate, and again we want arrow thing. So this coordinate was like B. Sorry, we don't have to use B, because B we defined after this. So we can use O here, yeah, or we can use this coordinate B. Let me, what can be done, let's put this coordinate, let's say B, and where we put it B, let's comment this line and then comment this line as well. Let's see how we can, yeah. So as you can see, nothing changes, because we reference this coordinate as B because of this rectangle part, and initially we reference this point according to this curvature. So actually B coordinate is actually same as before, that's why. And there's a benefit of doing this is like now we can reference B from here. So this is the B coordinate, and from B we want like H unit towards rightward and minus H towards leftward, and from there we want X and minus H, and we can name this as G, and we can say midway right. After saving we're gonna see here arrow, yeah. So it is perfectly fine. So I guess H is pretty wide, so we can reduce this size. So 0. Let's say 75. So yeah, now it's fine. G is perfectly fine. And few more thing we have to do. G is represented, H is represented, and the most of is no. This, let's represent this part firstly. So again we have to use TZ line relative coordinate, and we have to do arrow thing because it's representing the vector quantity. And from V we want like H actually dimension. It does not have to do with length or something, so it is u naught. So let's say vector u underscore naught, and we want towards right. That's why in the square bracket we provided the optional thing. So as you can see, it's u naught, and we can increase its length. Let's see how it seems. Yeah, it's pretty fine, so no problem I guess. And a few more things are remaining. It's like theta and this velocity, and most difficult part is already remaining. It's like the particle thing, how we're gonna draw this particle. Yeah, I have a few ideas about that, but I think we have to do a bit more. Let's move this a coordinate a bit upward so that we can reference, or no, do not move. Let's draw, let's fill a circle 2 point, and then we can remove this starred origin. So B actually manually drawn a circle, and in few seconds you will get why we drawn a circle. And because to this circle we can shift towards rightward, leftward, depending on what we needed. So let's define the radius, because we don't want like million times 2 point. Let's for right now say 3 point. So just we have to reference capital R, and we want x shift is equals to capital R. So after saving, it will not look perfect actually. XS is pretty fine. Let's see, 5 times x shift. So it actually not shifting. I don't know why. Let's use draw, then maybe draw, and then maybe. No, it is not doing the job. That's because we are referencing A, maybe. I don't know why, but it is not working here. 5 times R is pretty nice, I think. I don't know why. I told you already, making this particle is the most difficult part in this diagram, and it should feel like the particle is on the tangent, and that is the most difficult part. And yeah, I have a few ideas about the tangent marking the coordinate, but that will be pretty like difficult to solve. It's like it will take an hour. Let me see. Oh yeah, broadcast is still going. 5%, yeah. I don't know what to do for that. It is not shifting. So let's do the coordinate calculation. That will do the job. So fill, and from A we want like 0.1 unit and 0.1. It's like above and right. So yeah, I got it. But let's say or we want 0. Yeah, so it's pretty okay. It will do just job. Yeah, particle is but let me decrease the point size. 2 point will be fine, I guess. So I think it looks pretty fine. And yeah, we can use the draw version, not the fill version, but I think it's fine. And one more thing, now you know what we can do if shifting doesn't work. Sometimes yeah, shifting in Tikz doesn't work properly as we expected. So now we have to put this circle here as well before the velocity v naught. So where we put it velocity v naught, sorry, u naught at the b. So yeah, we put it here. So yeah, we can draw this circle here as well. It's like, oh come on chat, here, but we can use b. And now we don't want to be shifted along x, we want shifted along to be along, sorry, along y. So we replaced by coordinate as capital R. And as you can see, it is at edge. And even we can do minus r because it is like exactly at this. So and now we can shift this arrow thing, like v naught should be in. So that's why we defined actually, oh sorry, come on z0. And yeah, we have to use relative coordinate here. So let's copy this coordinate and paste this completely, and it will do the job. So as you can see, it is perfectly fine, as you can see. So our most part is done, I guess. Let me zoom out. Yeah, it seems nice. It seems nice. And yeah, one more thing we have to do is we have to represent this ball as little above. So we actually plotted the C thing here, and again we have to it's like we have to use the previous coordinate, but instead of that we can use C now, and we want it shifted to be radius unit upwards. So yeah, as you can see, it is perfectly. And then after inside the radius we can reference R, which is universal for all these. And I think most part is done. And one more, yes, we have to reference this as R, so that radius will be uniform for every particle everywhere. So yeah, it's done. But few more thing is there still after 1 hour spending on this diagram. I sometimes I think it's a waste of time to make diagram in Lattice. Like it's easy to use Illustrator or any basic app to make these kind of diagrams, but I guess at the end it feels worth it to spend 1 hour on this diagram. And most part is done. Few things there to draw, like firstly theta thing, and then after is velocity thing. So theta will be I think not be that easy. Theta will be quite tedious. What we can do for theta, because theta, yeah, we can kind of manipulate in a easy way, but that won't suffice the beauty of this picture. Look, I want to do like this. So firstly I wanna like make a tangent, and from there we can make theta. That will be the geometrically perfect theta. But making tangent is not very easy at this point. I think I have to think about that. And one more thing, for the velocity of this part, still we can represent v as like absolute quantity thing, but that will be wrong, I guess. So for again for this geometry we have to find the tangent, and then after we can like draw a vector velocity. For that, what should we do? What should we do? Let's for right now just go with the theta as simple as possible. So TZ angle mark angle mark. So we want like from B to C to A. Theta. So as you can see, this is this is the theta. No, sorry, we have to use O here. O. So theta is fine, but as you can see, there is a error. That's why I don't want to do like this. So yeah, we can fix that part by shifting a bit, but as you know, it won't be like perfect as it should be. So let's fix this problem by like jugaad. So we want as unit upward, that will be fine, and let's not 1.5 unit. So yeah, as you can see, we fixed pretty well. So this will be dashed. Doesn't need to be dashed, but dash looks no solid. So I guess thick. Theta, no. So let's not do anything specific. Let's say 7.5. For more we can, yeah. So as you can see, it's like a trial and error to fix this theta, but as you know, it's not perfectly right. So yeah, theta is okay for right now. For diagram purpose, it's okay to manipulate a bit and then keep it that way. And few more thing, one last thing we have to do is to make this velocity, and for velocity as well, we can do exactly trial and error thing. We can go from C to relative coordinates like 1,1 will be fine, and we want velocity. So velocity is vector, so we can put V and towards above right. So as you can see, its velocity pretty weird actually. We have to fix. It's like 0.5 unit, and it's like 1 unit. Let's keep it that way right now. So yeah, it's okay, but as you know, it's not okay. 0.8. So yeah, it seems like velocity is perfect, but you know that it's not okay because of the tangent thing. So for representational purposes, it's okay to be look like this. So I guess this picture is completely done here. Let me few more things. As you can see, I guess we have drawn this drawing much better in compared to original, or the same, I don't know. In the original diagram, it is not kind of in proportional, so we can do this, but it will look nice, but it won't be like that proportional in compared ways. So we can fix that because we want that A coordinate to be at greater height. So where is A? So we have this coordinate O. Where is A? Sorry, where is A? Yeah, it's here. So yeah, we can do is like we can use 5 unit. No, that will like destroy the whole drawing part. I guess it's fine. It does not have any problem, but sometimes I feel like I should be 4 unit H. Let's try. Doesn't matter it will miss thing or not, but I guess it should be fine. So not 4 unit, it's like what should be the shifting. Oh, we want 3.5. yeah, so it's fine, but as you can see it is messing everything up. So let's keep it as it was originally. So yeah, it's fine, no problem. Let's move on to next diagram. So this is problem number 2, and we have to make a prism here. We can make a right angle, it will look like prism, but I actually wanted to make this prism and pretty accurately. It's like we can change size and all these dimensions and it should shift accordingly, but I'm mentally tired. Okay, I will draw next day or in the evening, maybe tomorrow. So right now, thank you for watching, and see you in the next live session. Hopefully hopefully you have learned something in this live session. I don't think you have learned pretty like great thing. It's like pretty basic thing, and by only watching tutorial you won't know anything. It's like you have to do things manually, you have to apply in your daily projects, and then after you will start to feel comfortable in all these drawings and all. So yeah, get things done. Okay, thank you.